This video will cover transforming an integral into Riemann sum. Evaluate integral from 1 to 4, 2 minus x squared dx. Apply definition of Riemann sum using a right-hand point formula. Recall the right-hand point formula, integral a to b, f of x dx is equal to limit n goes to infinity, summation I goes from 1 to n, f of a plus I times b minus a over n times b minus a over n. This is xi, and this is the function f of xi, and this is delta x. A is equal to 1, that's the lower limit. B is equal to 4, that's the upper limit. And delta x is b minus a over n. That's 4 minus 1 over n, that is 3 over n. Xi is a plus I times b minus a over n. That's going to be 1 plus I times 4 minus 1 over n. That's 1 plus 3i over n. And the function f of xi is equal to 2 minus xi squared. That's equal to 2 minus 1 plus 3i over n all squared. So the integral from 1 to 4, 2 minus x squared dx is equal to Riemann sum limit n goes to infinity, I goes from 1 to n, 2 minus 1 plus 3i over n all squared multiplied by delta x, which is 3 over n. We need to do some algebra and simplify this. So we have 2 minus 1 plus 3i over n times 1 plus 3i over n. That's 2 minus, multiplying this out, folding it, 1 times 1, that's 1. The middle terms will add up to 6i over n. And these two terms multiply out to 9i squared over n squared. Distributing the negative sign, 2 minus 1 is 1, minus 6i over n, minus 9i squared over n squared. So r is going to be the limit, n goes to infinity, I goes from 1 to n, 1 minus 6i over n, minus 9i squared over n squared, times delta x, which is 3 over n. This is a limit as n goes to infinity. Let's multiply 3 over n right through. That's I goes from 1 to n. That's 3 over n minus 18 I over n squared minus 27 I squared over n cubed. We're now going to split up the summations, but first we need to know some summation formulas. Summation 1, I goes from 1 to n. This is just n. Summation I goes from 1 to n. This is n times n plus 1 divided by 2. Summation I squared, I goes from 1 to n, is n times n plus 1 times 2n plus 1 divided by 6. So let's split up the sums. So what we have is a limit n goes to infinity, I goes from 1 to n, 3 over n, minus 18i over n squared, minus 27i squared over n cubed. This is going to be equal to limit n goes to infinity, summation I goes from 1 to n, 3 over n, minus limit n goes to infinity, summation I goes from 1 to n, 18i over n squared, minus limit as n goes to infinity, summation I goes from 1 to n, 27i squared over n cubed. Now the 3 over n can pass right through the summation because it doesn't depend on I. 18 over n squared can also pass through the summation because it doesn't depend on I. And similarly, 27 over n cubed can pass right through the summation because it doesn't depend on the subscript I. So what we get is limit n approaches infinity, 3 over n, summation 1, I goes from 1 to n, minus, limit n goes to infinity, 18 over n squared, summation I goes from 1 to n, minus 27 over n cubed. Let's put a limit n goes to infinity, summation I squared. Okay, summation 1 is just going to be n, summation I is going to be n times n plus 1 divided by 2, and summation I squared is going to be n times n plus 1 times 2n plus 1 divided by 6. So simplifying this, what we're going to get is, we're going to get limit n approaches infinity, 3 over n times n minus limit n approaches infinity, 18 over n squared times n plus 1 divided by 2 minus limit as n goes to infinity, 27 over n cubed, n times n plus 1 times 2n plus 1 divided by 6. The n's cancel out, so clearly we're going to get a limit as n goes to infinity of 3 minus, and we're going to get a limit n goes to infinity of 9 times n squared plus n all over 18 over 2, that's 9, all over n squared, minus 27 over 6, limit as n goes to infinity of n squared plus n, if you multiply the n by n plus 1, times 2n plus 1, all over n cubed. Now it can be shown that this ratio will approach 1, and we're going to show that in the next step. And this ratio is going to approach 2. So, the answer is going to be 3 minus 9 minus 27 over 6 times 2. That's just 54 over 6. It's 9. 3 minus 9, that's going to give us minus 15. So let's show a little bit more detail on this term, why this ratio approaches 2. So what we have is limit n goes to infinity minus 27 over 6 n squared plus n times 2n plus 1 divided by n cubed. This is a limit n goes to infinity minus 27 over 6. Let's multiply these two terms, folding it all out. That's going to give you 2n cubed plus the middle terms add up to 3n squared plus n all over n cubed. Now we're going to divide by the highest power in the denominator. Limit n goes to infinity minus 27 over 6 2n cubed over n cubed plus 3n squared over n cubed plus n over n cubed, and also divide the denominator by n cubed. We get n cubed over n cubed. We get minus 27 over 6 times, that's 2, plus 3 over n squared cancels n cubed, leaving n in the bottom, plus 1 over n squared, all over 1. Let's take the limit as n goes to infinity. Clearly, this ratio, 3 over n, will go to 0 because it's 3 divided by a very large number. That's going to approach 0. And similarly, 1 over n squared is going to approach 0 as n goes to infinity. So what we get is minus 27 over 6 times 2 plus 0 plus 0. That's just minus 54 over 6. That's minus 9. So what we have shown is that the integral from 1 to 4, 2 minus x squared dx, was transformed into a Riemann sum, and the answer came out to be minus 15. All right, thanks.